All right, folks. Good morning. Welcome to DSS 2022. We're very glad that you folks can make this time. I'm here with Ananda Bose today from Confluent, and today we're going to talk about accelerating your modernization with Confluent and YugabyteDB. You're going to hear about how to build those resilient, scalable, event-driven architectures with both of our solutions together, and also go through some of the real-world challenges as we see in the industry. And then we do have a case study at the very tail end on how we've actually solved some of these challenges together as well. So with that, I'm going to quickly introduce our special guest here today, Ananda Bose. Ananda, do you want to quickly introduce yourselves?
Hey, good morning, everyone. And thank you so much, Amey, for inviting me for the session. It's a pleasure. My name is Ananda Bose. I live in McLean, Virginia, and I am privileged to work with some extraordinary solution engineers covering the US Northeast and Canada at Confluent.
Thanks, Ananda. And folks, again, I'm Amey Banarse. I lead the global field engine here at Yugabyte. Think of us as very similar to Ananda's role, except we focus more on the database modernization and helping the users and Fortune 500s to basically help them modernize their legacy database architectures when they're running mission-critical microservices to more cloud-native scalable architectures as well. And in this, we get to learn a lot about their domains, as well as help them basically create positive impact on their businesses as well. So with that, we have a pretty tightly packed agenda for you all today. We're going to go through some of these topics, obviously, but the most important part will be that keep this interactive. So please ask us questions on chat. Pause us at any point. We're happy to answer any of your questions real quick. More importantly, this is something that we have put together from our past experiences as we have been working towards working with Fortune 500s in joint solutions capacities as well. So with that, Ananda, do you want to kick it off with some of the high-level agenda items you had in mind?
Yeah, so one of the things that we are seeing in the industry is the vast adoption of microservices in terms of what modernizing experiences for customers and employees, and also in terms of just reducing the technical debt and TCO that organizations today are working for. Right now, this and I'm going to use a cliched term, which is that COVID accelerated this like crazy. But everybody today is an internet business, right? There was earlier a clear divide between Silicon Valley and traditional enterprises, but that's simply just disappeared. So most organizations that we deal with are also looking at, how to eliminate dependencies between the various teams that are working on application development, and of course, build and integrate highly scalable apps, that further reduce their technical debt and TCO. So that's a big movement that we are seeing. And the other movement is the usage of open source or committer-driven tech, which is just amazing in terms of the take-up. And, I guess, Amey, both you and me should be privileged that we have this great opportunity, to participate in this movement. And, the real problem, Amey, started with monoliths, right? Nothing wrong with it, right? I mean, you can call me old, but I've seen this transition from 3270 screens to, at least HTML-based interfaces, right?
Right.
I've been through a SOA migration in my life. I've been through MQs. I was so happy when MQ first came because, now you didn't have to write object-oriented C to call, messages from one part of the world to the other.
Right.
But the result was that as different systems and services came up at various points of time, the integration became so complex over a period of time that if you look at the architecture on the left, the major problem that you have is that any change that is requested is too difficult to actually deliver in a tested and easy to consume manner. So let me give you an actual example, right? So you have, let's say, a credit card company which needs to come to the market. Now, they have an option to build everything on their own, or they basically go to a processor, which could be a bank, and want to connect to them. And they want to connect their systems to several other banks, because they don't want to process with just one. It is so hard today. It can take anywhere between 3 weeks to 9 months, And because of this, what's happening is that there is a lot of reliability issues that are coming up in the current architectures, and it's too expensive. So expensive in terms of money, expensive in terms of risks. And that's why this whole wave of decoupling is happening. And, that's the, if you give a click, I'll just probably share, that's where the microservices movement is making this so, that's where we see this explosive growth, because microservices allow you to decouple your dependencies.
Right.
If you look on the left side, the business logic is at the UX, the business logic is at the messaging, it's at the database, it's at your BPM layer, anywhere. So imagine what happens when a change is there. Microservices tries to flatten that out. You have faster release cycles because you can release one microservice at a time. You have way improved scalability and reliability. You don't need to scale everything together or make everything available together. And most importantly, you don't have to choose what development method you'll use, what development framework you'll use, what development language you'll use, because that is what microservices allows you to do. However, even though microservices seem so great, it is quite difficult to move from the left-hand side to the right-hand side. And
Yes.
I guess that's the core of our conversation today.
No, totally, Anand. And it's a journey. Like, you brought up a good point about financial services and fintech industry. And you see, especially in APJ, we work with a lot of consumer fintech companies who were trying to go and recreate this new way of doing peer-to-peer payment systems, recreating core banking frameworks, right? And they are really consuming these microservices and new cloud native, like the entire CNCF stack, so that they are more scalable, they're closer to where their consumers are deployed. So the latency and the throughput game is much, much different from the older legacy banking infrastructure that used to exist back in the day as well. So this is a very, very great point. Let's go to the next one.
Yeah, and good or bad, there are two really strong approaches in terms of data interchange, right? You spoke about peer-to-peer payments, anything. So most of them today will be using one of the three, okay? They'll use REST APIs, they'll use message queues, or they'll be using Kafka. Pretty much these three, rule the roost. It would be, I would struggle if any of the new modern internet, integrators or internet systems are still using JMS, but I'm not so sure. But either one of these three is what it would be. So REST is great because it's a easy to consume method, allows you to consume through a multiplicity of different formats like JSON, Parquet, Avro, anything. But it has its challenges. So as the number of services, as the number of REST interfaces grow, there is a lot of tight coupling that happens. Now, tight coupling again defeats the core of what we want as decoupling, right? The second thing is that scaling then becomes difficult. Kubernetes has improved this dramatically, but the thing is that you don't have only what we call as services that do not need to persist. There are situations where services need to persist, right? So, and last but not the least, if you're going to manage this at scale, there's quite a significant investment in terms of observability, in terms of management, monitoring, etc. Right?
Yeah.
So that's where the asynchronous pattern starts coming in. And that's a great segue to the next slide, because queues have been around for a great amount of time, right? And queues allow both synchronous and asynchronous, but queues cannot store data. So queues, when you cannot store data, then how do you actually, or events, then how do you actually manage, the decoupling, like we said, from, the UX to microservices to the database.
Right.
So we have two available technologies. They work great in their own little niches, but they don't satisfy the requirements on the whole offer end-to-end internet business, right? So moving on, what we see is that, Confluent and Yugabyte come in and actually help you to solve this pretty nicely in a pretty nice and efficient manner.
Yeah.
So what is this great solution that we are going to talk about, Amey? So Confluent, starts changing the game by looking at things that are happening in your enterprise or your business from the perspective of events. Now, nobody talks to you about table or a field, etc. on the business parlance. They always talk about events. An event is a payment, an event is a shipment, an event is a complaint, etc., etc. And what Confluent has done is this: they have created this platform using Apache Kafka, because our three founders, Jay, Neha, and Jun, actually built this when they were in LinkedIn. And they have used this event data that is coming into our platform, process it, and this can then be used by a variety of downstream, applications like Yugabyte, or even front-end applications for either rich customer experiences or for operational needs. And we have several customers, all over the world, and KeyBank in the US, literally reimagined their bank by looking at, events as the core source of business. as opposed to, looking at it from a pure, data or a message kind of paradigm.
So Yugabyte essentially is a distributed SQL database. So think of it as like, we kind of took like, those hardest problems in the relational database industry. And we thought like, how can we build that next generation cloud native database, which handles scale, resilience built into its architecture, so that replication of data or sharding of data is not basically an overhead for an operator or a developer, but completely handled by the architecture itself. And that's what we brought into the industry as innovation in 2016. But we started with that open source DNA, similar to you folks, right? We are 100% Apache v2 licensed. And since it was 2016 and containers were up and coming, and most of the VMware deployments were really, really well as well, whether it's VMware OpenStack or any Zen-based systems as well, we ensure that our product can be deployed on any form factor. So it's platform agnostic. So that is, you can deploy it on public clouds, private clouds, Kubernetes, bare metals, virtual machines, doesn't matter. You get the same exact experience with those cloud native properties: observability, manageability, Monitrix, integrations with Datadog, or any other log aggregator kind of frameworks as well. So that was like one of the primary things which basically helped us go displace some of the existing legacy databases in especially mission critical microservices kind of applications as well. And the best part is that the developer friendliness of the APIs, and this is where I'm going to speak maybe for like a quick 30 seconds about, because it's great to have a database, but there are 200 database vendors out there, right? Every time the new database is launched, a developer has to now think about, how do I change my data model? How do I rewrite my existing query that I just invested 2 years ago into a brand new thing? This was a problem we wanted to solve for, and also help Yugabyte increase their developer velocity by bringing in those friendly APIs to the market. So what we did was, even though Yugabyte is built from scratch database, we actually have Postgres compatible API, like a full upper half of Postgres query layer sits on top of this brand new Yugabyte database in there, which allows you to have that 100% code compatibility. Yes, there will be cases where you need to somehow optimize your schema for distributed nature of the database, because there's network element and everything attached to it. And also the second API that we have is Cassandra compatible API. If you have a key value kind of a store, kind of an example, or let's say you have semi-structured data and you want very high throughput, low latency with that, you basically get those two developer friendly APIs with it. Rest all, you get asset compliance, you get security, everything built into the system. And we'll talk some of this as well in a bit. Now, tying it back to the event-driven architectures that you mentioned, Ananda, one of the core things in Yugabyte, again, because of our open source DNA, we've highlighted this fact early in the game that we built our own CDC framework, which integrates with Kafka Connect, which just opens up a variety of new event-driven applications for us. So for instance, rather than getting into technology, I'll give you some live examples that you can actually feel. You see any General Motor cars here on the US roads, they basically stream data into Kafka pipeline, which gets into Yugabyte. And Yugabyte then acts as a core system of record to serve that data to downstream applications. And these are very important applications like vehicle data factory, health checks, all of these important ones, right? Similarly, one of the largest retailers on the planet does very similar things. Overnight takes the Kafka pipeline, creates separate topics for separate different product lines, and then gets that data into Yugabyte. Similarly, for large financial services, that the example that we're going to cover later today. So the most important thing here is that we see this combination of Kafka, Yugabyte, and let's say Spring as one of the microservices framework really being reused and reused a lot in Fortune 500s, because that's a typical design pattern to develop the scalable, resilient microservices architectures right now. And we should definitely highlight some of these for our audience later today.
So why build with Confluent? Number one, it's an asynchronous plus synchronous method of service communication and development, right? So once you do that, you can decouple the communication as well as your data integration requirements from your backend source systems, aka reduce your bill on a lot of monolithic backend source systems, right? Number two, you can use clients, you can use standard REST APIs. So you have the capability to do pub/sub messaging at scale, or you can use a client or a connector, whichever mechanism suits you best for your use cases, right? Confluent Cloud allows you to elastically scale up. So we have a client, we have several clients actually across the world who regularly scale up elastically their CKUs massively during the NFL season, for example, or during large shopping events, or during taxation season, right? So it's just amazing. You can store this data, and when we go to the use case and the actual customer example, I'll share with you how this is valuable. And last but not the least, you can process data in flight as well as real time, which used to be a very complicated method in the earlier part. And these are solid reasons why you should build these kind of architectures using Confluent. But the other element that you have, especially when you are dealing with data, is again governance, right? Am I getting the right data? Is the schema correct? And one of the things that Confluent Schema Registry allows is to get the right data into using the connectors into Yugabyte, right? So you as a developer don't need to worry about schema validation, etc. I mean, I remember back in the day, we had to literally have an ODS where we used to do all that we used to do was table to table mapping, right? And we used to even have I remember banks having as many as 800 people doing, just this kind of, is this schema and is this schema mapping for end of day processing. So Confluent Schema Registry eliminates a lot of those kind of problems, and it's a fantastic governance tool. And I think the other big thing that's there is you spoke about the distributed SQL API, right, at length. Having those kind of capabilities, reduces a lot of complexities, especially from a developer. I mean, as a developer, truth be told, I know more of Java or .NET or Go than SQL, right? So when I have an API-based approach for consuming data, it is much more easier for me as opposed to, trying to learn SQL and, joins and complex joins, etc.
Correct. And actually, that's a very good point because, we also run into, a lot of really enterprise developers who are very strong with the languages, but not with SQL. And the best part here is that, something like JPA connectors, like Spring Data JPA, we piggybacked on that. We created a Spring Data Yugabyte so that you don't have to write those complex SQL queries now. You can totally leverage the application framework that you're using of your choice, whether it's on Java or Node.js, and rely on those queries that are created to go do the right thing with Yugabyte as well. So that's actually a very good point, and also helps you increase the developer velocity tremendously in those things.
Yeah, and the next one, obviously, I know you touched about RPO 0. I mean, internet businesses are 24/7. So whether you like it or not, it has to run over multi-regions, multi-geographies, with zero data loss kind of scenarios, right? High failovers, low latency, etc. So both Confluent and Yugabyte are built for this. We are distributed from the core, which means that we have this capability where not only can we support your SLA. I mean, for certain that Confluent Cloud now offers 99.99% availability, which is a tremendous SLA. And again, to hit on this, when you're dealing with cross regions, etc., in a global kind of organization perspective, right? Your end-to-end governance of the flow of data is very, very important. So Confluent has recently released Stream Governance, which allows you to look right from source to sink, as well as the processing of all the information. And this is of great information, not just from an audit perspective, but from debugging, understanding bottlenecks, and sometimes even business applications like tracking mortgage applications, etc.
Both of us basically belong from the open source DNA, and we are here to displace the legacy monoliths of the world, or the largest of the companies here on the planet from software revenue perspective. But the core goal here was demonstrate how those business metrics can be achieved with lower TCO and lower technical debt, integrating very well with the CNCF ecosystem of products and things like that to make sure that you can have this reliable, scalable design patterns without any overhead of managing it or observing it. And that's where the whole thing comes in. So I can talk quickly about the Yugabyte ecosystem, wherein because of Postgres, we get most of the ecosystem for free, quite honestly. And we then double down on taking some of those core ones, which needs some distributed mechanisms in it. And we basically curate them and then make it available to the community. It's a lot of community-driven approach because our customers, the consumers of the technology as well, commit it back. And if you go to our GitHub, you can see entire roadmap live in open with every single tracking item from that standpoint as well. Would love to know your story as well, Ananda.
Yeah, I mean, we started in a similar way, right? So we had the Kafka ecosystem, and it started with 5 connectors, and then Divisium came in with their own connectors. We built a ton of connectors. So right now, I don't remember what is the last count, but I guess 120 is a fair number. But we also have premium connectors now, which connect, like source from Oracle, then source or sync to SAP, Salesforce, Splunk, etc. And these are all connectors that are supported by Confluent completely And they allow you to obviously leverage our computer-driven expertise that we are so proud of, in the industry.
That's perfect. And Anand, this is something like, we are investing heavily. So very soon we'll have this Yugabyte marketplace approach, very similar to Confluent Hub, where developers can go pick and choose their connectors and start using it right away from our cloud product as well. So that's great. So Ananda, let's get into some of the gory details, like how we actually do this at scale as well.
Yeah, and I'll take the most complex use case. Let's take the good old mainframe, right?
Yes.
That's where a lot of the data in the world resides today. And everybody wants to take this data from the mainframe, example, and account balance, right? It's kind of funny, and I give this example that everybody nods their head. Before COVID, we used to check our bank balance maybe 4 times a week on our mobile or internet banking. After COVID, we check it 20 times in one day, even though nothing changes in our bank balance, right? Why do we do it? Because we just have it and we are fiddling around with our phones, right? Guess what? Each of these transactions is generating a bill to someone, at the back end, because most of the backend systems charge as per millions of instructions per second and things like that. So one of the first things that we do when we actually start this microservices journey is to make the synchronous call into an asynchronous call. Right. How do you do it? So the way we do it is through a CDC connect. Confluent connects to a variety of CDC connectors like IBM, Infosphere Data Replicator, Attenuity, which are pretty popular in the mainframe arena. We can, if you are using MQ series primarily as your method of integration, then we have a legacy MQ connector. If you're using TIBCO, we have a JMS connector. And essentially what that allows you to do is to take the events as they're happening in the backend systems and serialize them in a method by which it can now get into Confluent brokers. Once it is in the brokers, we typically enrich them either depending on which way you look at it. If you're a Java person, you use K-streams, which is the Java Kafka API, or you use KSQL if you're more of a SQL-oriented person. What are some of the things that you do? So an example is, if I want your balances at that particular instant, so I get the data from all the systems, but I stitch it together, using Confluent, or I may even decide to pass it to Yugabyte directly through a sync connector. But depending on the architecture, I make it available, right? So once I have this data in the brokers and in the topics, I then use a sync connector and pass it to a Yugabyte or a similar store. And then from there, it gets consumed. Now, what happens on the other side is that from now on, all the consuming apps on the front end, they don't need to go back anymore to the mainframe anymore. They will just come either to the Kafka brokers or to Yugabyte and get the most up-to-date data, because all of this CDC is sending all of this information into the Yugabyte area or the Confluent brokers.
Correct.
A ton of money you can see. And tremendously easy for change to happen. Because assume if a Lyft asks for a specific interface, you give it so easily. Right. Someone else asks for a different interface, you give it so easily, right? So remember our tenets, it flies into that really well.
Yeah. So Ananda, I just wanted to highlight this one thing, like that is at Yugabyte, we basically are a little bit more opinionated because there again, as I mentioned, tens of these legacy databases that power some of the largest applications in the industry. And what we do is we take that opinionated approach to basically help them, if they're already on the microservices path with digital transformation, we help them pick and choose the right databases for the right applications. And whenever Yugabyte is the answer, we actually help them modernize their database architectures to be more scalable, resilient, and foolproof in case of a disaster. Take, for example, Texas power outage from last year. We ensured that this large retailer had no outage, even though their Oracle and Oracle-derived systems took a 4.5-day outage between that, right? Those are the things we do with customers. And a couple of things like we do in that case, essentially keys to success, I would say, is basically making sure that we understand how their data is flowing, the data architectures itself. How do they do change data capture? How is the data landing? What kind of application throughput do they expect and things like that? So I think the net would be having a case study for our audience today and how we put this together jointly, right? So the case study here is, again, we have blogged about it, so you folks can go and read this at length. But a quick snapshot would be that this is a large financial institution, a real life case study where we started working as Yugabyte with them in 2019 to really go and help their mission critical tier 1 applications, which was running on DB2. And they were already on their way to go break the monoliths into microservices and run it on something called as Pivotal Cloud Foundry, the microservices set to run Spring Boot applications. And with that, just the way DB2 was structured and the amount of time it required them to go rack and stack and make it operational was in months, which obviously reduced the developer velocity and just couldn't innovate at scale for their developers and their businesses. So the way we did that is basically having Yugabyte in there and doing a change data capture from their DB2 to get that data into Yugabyte through Kafka. We started with the read volume first. We ensured that all the read volume started coming to Yugabyte, but the writes kept going to DB2 for some time. And then as a journey over the next 6 to 9 months, we started capturing all of the reads and writes into Yugabyte. Again, the latency was obviously going to be slower because Yugabyte can run anywhere. So in this case, it runs very close to where microservices were deployed with scalable guarantees. Like you don't have to wait for months to rack and stack. This is a matter of hours to go scale up and scale down the cluster, even in their private cloud solution. But Ananda, since you're a subject matter expert in this one, would love for you to help our audience understand, what does this IIDR mechanism here really do? Like, how would you do the CDC from DB2 into Yugabyte using Kafka and this component itself?
Yeah, so the IB mainframes are either DB2 or they are IMS, right? Or VSAM. So now all of these are data storage formats of some kind, but obviously it's different. What IIDR is a tool that is available from IBM, and there's a similar competing tool called Click Attenuity, which are well integrated into this mainframe ecosystem. And it has the ability to take from the log, all the log entries, and provide a serialized format through a connector into Confluent. Once you have it in Confluent, we can then do basic processing. So I don't know if most of you have seen mainframe data or not, but it's a load of files that come very small in size, but huge volume. And what Kafka does is then processes this by removing a lot of things like nulls, doing joins, roll-ups, multi-joins, etc. And then it syncs it into Yugabyte. So variety of use cases then emerged. I told you about the balances use case. The balances save a lot of money for most companies, right? The second one is notifications. So any change that happens, you get notified. The third one is end-of-day processing. Now, if you look at a normal architecture for end-of-day processing, it'll be anywhere between 8 to 10 hours. This kind of architecture reduces the end-of-day processing to 2 to 3 hours.
Right.
That is a huge benefit, right? Because I don't know, most folks here would probably underestimate what is end-of-day processing, but I can definitely say for this specific institution, between the US, India, and some other outsourced areas, there were hundreds of people involved in the end-of-day processing.
Right.
Along with, the time. So if your systems do not complete all their processing at the end of the day, next day, your bank, your retailer, nothing opens up. So there's a variety of use cases, that comes up. I mean, in the case of credit cards, it is even something even more significant. It's fraud.
Right.
Imagine if you get a fraud alert one day after you had the fraud event. That's going to kill you, right? You have to have it in seconds, So a lot of this kind of stuff. There were some other interesting things that happens in this kind of architectures. Mainframes create a lot of duplicate data. So using dead letter queues, for example, for removing the duplicates. You'll be stunned to see there are offshore teams that remove duplicates, in many financial institutions. So on the whole, it reduces technical debt, it increases developer velocity, and it makes you ready for, prime time. That is the internet world today.
Ananda, any closing thoughts before we start answering some of our audience's questions today?
I think, Amey, thank you so much once again for making me part of this wonderful event. And I would really say that folks, get onto education, get onto the managed clouds, try and use some of the services available. I'm assuring you it's going to open a new world to you in terms of application development.
Thank you. Ananda, thank you again for your great insights today. Your experience really, really helps our audience and obviously absolutely across the industry as well. So thank you again. And folks, we'll start taking questions now.